Lesson 4.4, Parallel and Perpendicular Lines. In this video, you will learn to write an equation of a line that passes through a given point, parallel to a given line, and you'll write an equation of a line that passes through a given point, perpendicular to a given line. So in order to do that, you need to know what a parallel line is and what a perpendicular line is. So just a quick review, parallel lines, they go in the same direction, and they have the same slope. Okay, perpendicular lines intersect and form right angles, and they have opposite reciprocal slopes. For example, if one was A over B, the other would be negative B over A. So opposite, you switch the sign, and reciprocal, you switch numerator and denominator. Okay, so if I want to write the slope-intercept form of an equation for a line that passes through toward -2 and parallel to the graph of this. So I'm using this information just to find the slope, right? So we're saying that it's parallel to this. Okay, so if it's parallel to that, what I just said on the last slide is that parallel lines have the same slope. So looking at this, what is the slope of this line? The slope is 1/2. So remember our steps, the first thing to find is slope. So if it's parallel to this line, that means my slope m is going to be 1/2. Step 2 is to find the y-intercept. So to find the y-intercept, we use the equation y equals mx plus b, and I use my m and my point. This is my x and my y. So I plug in those three things, -2 for y, m we just said is 1/2, and my x is 4. And now I only have one variable, b, and I can figure out what my y-intercept is. So 1/2 of 4 is 2. So -2 equals 2 plus b. I subtract 2 to get b by itself, and I get -4 equals b. So once I have my slope and my intercept, my third step is to write my equation in y equals mx plus b form, and I put in my m and my b. So y equals 1/2 x minus 4. And then that is the line. Okay, the next question. The height of the trapezoid is the length of a segment that is perpendicular to both bases. In trapezoid, ARTP, RT is, and AB are bases. Can EZ, so RT and AZ, AP, our bases. Can EZ be used to measure the height of the trapezoid? So the height of a trapezoid has to be perpendicular to the bases. So we want to see if those slopes are perpendicular. So remember, slopes, if they're perpendicular, if I have A over B, something that's perpendicular to it would be -B over A. So we want to see if we can do that. So to go through this, I'm going to figure out the slope of AP. So from A to Z, right, it goes 2 and 2. So it goes up 2 and forward 2. So the slope of AP is going to be 1. Okay, so then I want to see the slope of this one. So from here it goes up 1, 2, 3, 4, 5, 6, 7. So it goes up 7 and over 1. So that one is 7 over 1. Or back, so -1. So 1 and -7 do not have this relationship of A over B is -B over A. So these cannot be used to find the height because it needs to be perpendicular. Okay? All right, part B. The height of the trapezoid is the length of a segment that is perpendicular to both bases. In trapezoid, ARTP, RT, and AP are the bases parallel. Okay, so we were looking at this and we were seeing if that height was perpendicular. It's not, but we want to know maybe if these two lines are actually parallel. So we want to see if those slopes are the same. So I'm going to erase this so we can take a look. So the slope we said of A to P, we said is 1. So for every 1 it goes up, it goes over 1. So 1 over 1, or just 1. So we want to check the slope of this one. This one also goes up 2 and over 2 from R to E. So 2 up and 2 forward, that also has a slope of 1. So because they have the same slope, yes, they are parallel. Okay. Example 3, determine whether the graphs of 3x plus y equals 12, y equals 1/3 x plus 2, and 2x minus 6y equals 5 are parallel or perpendicular. So here we can graph these to see what they look like. So let's start with this one here. We can use, we can put this, all right, well the y-intercept is going to be 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to be like up here-ish. Sorry. And the x-intercept, so putting in, before we put in 0 for x and got y is 12, now if I put in 0 for y, my x is 4, sorry. So we have 3x equals 12. So this is going to be one of my lines. Kind of like that. Try your best to draw it better than I. This one I can graph by using slope-intercept. So this is my intercept, so it starts at 2. And this is my slope, so it goes up 1 and forward 3. So this one is going to go like that. And this one, if I graph this, let's do 2x minus 6y equals -5. Let's put it in slope-intercept form. So if I do -6y equals -2x minus 5, divide by -6 to everything, and I get y equals 1/3 x plus 5 over 6. So starting at 5 over 6, it's a little less than 1. And then from there it goes up 1 and forward 3. Up 1 and forward 3. So connecting those, kind of, sort of like that. We can say, it's really poorly drawn, but it's supposed to be this one and this one are parallel to each other, and they're both perpendicular to that one, forming right angles. Okay, you can also tell it by looking at the slopes. So in this case, our slope is 1/3. Here, if I were to solve this for y, I would have y equals -3x plus 12. So the slope in this one is -3. And then the slope in this one, if I were to get y by itself, I did there, like this one is 1/3. Oh, wait. What did I just do? Anyway. Okay, example 3. Determine whether the graphs of 3x plus y equals 12, y equals 1/3 x plus 2, and 2x minus 6y equals -5 are parallel or perpendicular. Explain. So, there's two ways you can go about doing this. One way is to graph all of the lines and just look at them. So if I were to graph this one up here, I can graph that one using slope-intercept standard form, so like finding the intercepts. So if I put in 0 for x, that part goes away and I have y equals 12. So I can graph that right there. Okay, and then I can put in 0 for y and see what I get for x. So 3x equals 12 would mean that x is 4. And I can graph that there. So for that, if I want to draw the line through there, anyway, that would be one line. Okay, if I want to graph this one, this is slope-intercept form, so I can graph my intercept of 2, and then it has a slope of 1/3. So from there, it goes up 1 and forward 3, up 1, forward 3, and I get this line going like this. Okay, and then if I want to graph this one, 2x minus 6y equals -5. If I get x by itself, or y by itself, by subtracting 2x, I get -6y equals -2x minus 5, and divide by -6 each part, and I get y equals 1/3 x plus 5/6. So I start at 5/6, which is about there. And I go up 1 and forward 3. And I keep following that pattern. So if I do that, I'm going to get a line that comes down. It's supposed to be parallel to that one. So we can say that those two are parallel and they are perpendicular to this other line. Okay. You could also do this by looking at the slopes. So if the slopes are the same, they're parallel. So here we got our slope is 1/3, and here we got our slope is 1/3. So we can say those two lines are parallel. If I were to solve this one here for the slope, I would get it in y-intercept form. So 3x plus y equals 12. Getting y by itself, you would do minus 3x to both sides. So here, the slope is -3. So -3 is an opposite reciprocal of 1/3. So you switch it, numerator and denominator, and change the sign. So you can say those are perpendicular. Okay. Write an equation in slope-intercept form for the line that passes through for -1 and is perpendicular to the graph of 7x plus or minus 2y equals 3. So again, I'm using this just to find the slope. So I'm going through those 3 steps. First step is slope. So use the information they gave us. They said it's perpendicular to this, which means the slope of the line I'm looking for is going to have an opposite reciprocal slope of this one. So to find the slope, first thing I have to do is figure out what the slope of the perpendicular line is. So to get y by itself, I'm going to have -2y equals -7x plus 3, and divide everything by -2. And so when I do that, I get y equals 7/2x minus 3/2. So all I want from this really is the slope. So the slope of the perpendicular line is 7/2. The slope I'm going to be looking for is going to be -2/7. So that's step 1. Step 2, I want to find the y-intercept. So I'm using y equals mx plus b. And I'm using my slope and my point. So this is my x and my y. So I have -1 equals -2/7 times 4 plus b. So multiplying this, -1 equals -8/7 plus b. To find b, I'm going to add to both sides. So I'm going to have -1 plus 8/7 equals b. So this is like -7/7 plus 8 over 7 equals b. So b is going to be 1 over 7, which means step 3, writing my equation in y equals mx plus b form, y is going to be negative 2 over 7x plus 1/7, and that's that equation. Okay, so just to recap, parallel lines have the same slope, perpendicular lines have opposite reciprocals. And that's the end of the section. So you can do some of the extra practice problems if you feel led to.